Welcome to Exit Tutorial 1.07 Transformations 2. Our first question says, for a regular 15-sided polygon, what is the degree of rotation? Notice we have a regular polygon given to us, so we're going to take 360 and divide that by the number of sides. So this one is 360 divided by, my mouse is not working, 360 divided by 15. Let's go ahead and pull out our handy dandy calculator. 60 divided by 15 gives us 24. See if I can get there we go. Now my mouse is working. There we go. You can do this with any regular polygon. Which figures have rotational symmetry? Here you are going to take each of the figures, pretend like that there is a pin in the middle, and rotate them around. You'll notice that this one has rotational symmetry. As you turn it, it will land on itself. This has rotational symmetry. As you turn it or rotate it, it will land on itself. This does not have rotational symmetry. You would have to turn it a full 360 degrees before it would line back up onto itself. You get the idea. This does have rotational symmetry, 180 degrees. This does not. What is the least angle measure by which this figure can be rotated so that it maps onto itself? Notice that word maps. That means it turns back onto itself. So here you're going to turn it one time and it will map back onto itself. So this has a 90-degree rotational symmetry before it maps back onto itself. This, on the other hand, has a 180-degree rotational symmetry before it maps back onto itself. What is the smallest angle of rotational symmetry that maps a regular nonagon onto itself? Super important here for you to learn the names of the polygons. A nonagon is 9 sides. So you're going to do 360 divided by 9. Notice that it says the smallest angle. So as soon as you get how many rotations, you will see that that is the smallest rotation, or the smallest angle for rotational symmetry. We can keep going up from there. Each rotation will map it onto itself. A student uses drawing software to rotate the regular hexagon about its center. Through which angle measure can they rotate the hexagon to map it onto itself? You're going to do the exact same thing that we have been doing. 360. A hexagon has 6 sides divided by 6 is equal to 60. Then you have to continue. It's asking for all of the angle measures at which a hexagon can rotate or map onto itself. 60 times 2 is 120. 60 times 3 is 180. 60 times 4, and you can keep going. Make sure you choose all of the rotations where the hexagon will map onto itself. If you have any questions, please contact me via text or email.